Hi everybody, I'm Stancu. I'm with Highstreet Technologies, and I will try to present the OAM part here from the OAM software community. So OAM stands for Operations and Maintenance. And so I am currently a PTL for the simulations project, which realizes a lot of these OAM functions. But what I would like to touch upon today is, of course, a short introduction about the OAM architecture, because not everybody knows this. So maybe it's good to have a brief overview of what the OAM architecture looks like from the ORAN specification perspective. And then I want to touch upon how this is realized, so about the mechanism behind, which is Young schema mount. And then a few words about the simulated run management, which helps us prototype and POC a lot of the OAM functions. And then a brief overview about how an OAM test setup looks like, but we have already seen a lot of those diagrams today. So what does the ORAN specs tell us about the OAM architecture? So we have two modes. The first one is the hierarchical mode. So this means that an ORU is managed entirely by one or more ODUs. And for that management, a netconf-based M-plane, so the open frontal M-plane interface is being used. And the SMO connects to so manages the ODU through the OAN interface, which is also a netconf-based. But also has some other features like VESM file for fault and performance. So one of the main functions of the OAM is the FCAPS implementation. FCAPS stand for fault, configuration, accounting, performance, and security. So all of the configuration done to the network function or the alarms or the PM data come through this interface. And the second mode of this OAM architecture is the hybrid mode, which means that the SMO has a separate or can have a separate logical interface directly to the ORU, in addition to the logical interface between the ODU and the ORU. But we can see in both these cases the SMO has access to the ORU through the ODU, so it can manage the ORU through the ODU, so the data tree exposed by the ORU needs to be embedded in the ODU somehow. And how that is done is through this exact mechanism I was talking about, called Young schema mount. So in netconf Young, the Young is used for modeling the data, which is exposed by the network functions. So what happens here, we have the ORU exposing its open frontal M-plane Young models, and those are read by the ODU, and the ODU exposes its O1 Young models to the SMO through the O1 interface. So I tried to depict there that the models from the ORU are part of the models exposed by the ODU somehow. And how is this done? So the ODU needs to have a netconf client, so to terminate the open frontal M-plane interface from the ORU, so to read the data which is coming from the ORU and mount that or embed that into the data model which it exposes via O1. And this is the mechanism which is called Young schema mount, and it is used in the specifications of the Young models from working group 10, for the O1. And the mechanism itself comes from IETF, so it is defined in this RFC 8528, and what enables us is to mount one data model, consisting of any number of Young modules, that doesn't matter, at a specific location in the parent schema, in the ODU schema. But what it doesn't permit, it doesn't permit to have subsets of the data tree of the ORU exposed, but it needs to be a complete data model, yeah, embedded or mounted to that mount point. So when the O1 young models were specified, these labels were inserted in some places in the schema, yeah, which represent the mount points. This is where the SMO will find the information about the managed ORUs, but exposed through the ODU. Yeah. And I have here, I'm not sure how visible it is, but I tried to make it more real, yeah, more hands-on. So considering we have a netcom server, which is an ODU implementation, it exposes a data model, yeah, which we can see here, the O1 young models are defining a so-called aggregation base. So it's a young model where data can be embedded for different parts of the ORU configuration. And I have here as an example the ORAN aggregation interfaces. So this is the mount point where we can insert details about the interfaces of our ORU, but exposed through the ODU. So the aggregation here defines a list of ORUs which are being managed by this ODU. We have in our example 3 ORUs in that case. And for each of them, we have a so-called interfaces model up here, which is the entry point of our mounted data coming from the ORU. So what happens, the ODU connects via netconf to the ORU, gets the data associated with that interfaces, and mounts it or embeds it in its own data model, yeah, in the ODU data model, exposing it all the way to the SMO through this mechanism. But of course, describing this OAM, I needed to link it also to my project, yeah, so I'm the PTL for the simulations project, and part of what I do there is enabling a simulation of those interfaces, O1 and Open Fronthaul M plane, and of course that allows for rapid prototyping of applications and really hands-on playing, yeah, with this, because we don't have, when a new version of the standard comes, we don't have it readily available in the product, so in the open source OAI implementation and so on. This is why we need to simulate this management. And for example, we have here the RAN management simulated in the OSC simulations project. We have different network functions, currently ORUs and ODUs, simulated as separate Docker containers or Kubernetes pods. Each can have a different configuration, either day 0 or day 1. And, but this is not enough, yeah? So we need to go further, and instead of just having a simulated run management, we need to have to go towards a simulated run, yeah? So not just the management. So there is still work need to be done, and to enhance this, for example, a NE2 interface to be added such that we can also leverage the near real-time RIC and its functions. And also here we are seeing an example. This is currently a work in progress. So all the red dots are UEs which are moving through the map, and all the polygons there are simulated RUs. And when multiple users are connected to an RU, yeah, we have a darker blue shade there, meaning the load in that RU increases somehow. So this is work in progress. We would need this to insert AI into this, such that the generated data of that network changes over time and it's realistic. But of course, this is not intended to replace Ian's products there, so we don't want to to make a new super powerful simulator in open source that can replace all the commercial products, but having a more powerful simulator is intended, yeah, for academia and research, and really enabling new people working on this. And to do so, we need to leverage other open source projects which are out there. So we would need to integrate our O1 and Open Front-Hold simulator with other simulators that are out there in order to create a more, a more powerful simulation environment. And I would like to show just a little bit of the complexity of an OAM test setup. So we have up there the SMO, which in the OAM software community case, it's ONAP based. So we have different artifacts coming from ONAP, which are being deployed. And so we've seen this also in Michele's presentation earlier. We have different components that can be deployed. They can be either simulated, or maybe OAI, or a lot of, we can mix and match. But this is not an easy integration work. And I think BMO can confirm that. So there is a lot of work to do. As the previous speakers were saying, this is also a call for contributions. So any help would be appreciated to grow this community and to realize all what we are proposing here. Yeah. So I hope I didn't eat the minutes from the next presentation. So if there are any questions.